Hello everyone, and in today's lecture we will start with network theorems. There was some glitch in the videos uploading today, so I want you to join this link. I've shared it somewhere. Give me a minute. Okay, so what do you understand by network theorems in general? Tell me what would have been the probably would have been the requirement for a network theorem. Why were network theorem at the very first place being taught to you? So in a complicated network where you will find several nodes, in a complicated network where you will find several nodes, you're finding a lot of meshes, okay, a lot of sources, again, in particular independent sources, okay, a lot of sources. So in such cases, and they're acting what? They're all acting, these sources are acting simultaneously. And in such conditions where sources are acting simultaneously, now the requirement of your, in today's lecture, the requirement would be probably to, find out response in a particular branch. Okay. So if you intend to determine the response, if you intend to determine the response in a particular branch, then for in those cases we will use network theorems. Okay. So that was the to begin with, that was the requirement of network theorems. Okay. So in your syllabus, I've seen there are a lot of theorems that you need to study. One of them is Thevenin, Norton, superposition. Also, there is maximum power transfer theorem and so on. For today's lecture, we are starting with superposition theorem. Okay. Now, what is a superposition theorem, and what would it, uh, you know, what does it signify? Okay. So in a linear network with multiple independent sources, okay, let me explain it to you for once. Okay, let us say we have let us say we have to, I'm giving you a network. Look closely. And this is something that we'll also be solving as our question. Okay. So I'm drawing this for you. I intend to explain you what it is. What is superposition by concept, and then we'll take this question also individually. Okay. This, for right now, I'm writing this because this is a part of your question. So again, I don't want to draw the figure again. But for now, just ignore whatever is, like, whatever the value of IR is given to you. It is a part of your question, so I'm just drawing it so that I don't forget the next time when I have to explain you the numerical. But in any case, so coming back to my explanation, the first thing that it says, the first condition to a superposition theorem is what? The network should be what? The network should be linear. The network should be what? Linear. The second thing that it says is it should have multiple independent sources. Okay, so in our question, whatever elements that you see is what? The network is primarily resistive in nature. And what kind of element is a resistance? What kind of element is a resistance? Tell me. Resistance is a linear element. So this network in itself is what? It is a linear network. Remember, superposition applies only to what? Only to linear elements, right? Now, the response in a now there are multiple independent sources. Can I say there is this one source and this is another source? So there are two sources in this network. So yes, there are multiple independent sources. What do I want to what do I need to understand? For example, let's say there was some value of I given, say small I given to you, okay, and I intend to calculate the response in this branch. Okay, I intend to calculate the response in this branch. Okay, so if I intend to calculate the response in a particular branch, then in that case what will I do? I will consider one source at a time, considering the other to be equated to 0, right? Right? So, in this case that I am talking about, how do you reduce a voltage source to 0? Tell me, how would you reduce a voltage source to 0? Okay, what is a voltage source? What does this signify? This signify what? Potential difference. Now, if I say I have reduced this potential difference to 0, can I say I can replace this by a short circuit? If I am reducing a voltage source to 0, that means I am reducing the potential difference to 0, which means they are at what? They are at same potential. So, can I replace it with a short circuit? So, that is what my other line says. All ideal voltage sources are replaced by what? Are replaced by short circuit. Similarly, all ideal current sources are replaced by an open circuit. Again, let me tell you. How are you going to replace a current source, or how are you going to equate a current source to 0 when no current flows through a branch, right? So if this is your current source and I want no current to flow through this branch, only then the current source is equivalent to 0. Can I replace it with an open circuit, right? So that is how we do. So what do we do? What do we do? For once, we will equate this source to be 0 and calculate the response in this branch. That would be our part 1. In the second case, we will equate this source to be 0 and again calculate uh, the response in this branch, right? Right? So that is how uh, the resultant, the superposition theorem says, when we algebraically, remember, algebraically add the responses of both, when we algebraically add the responses of both the cases, then we get the effective response if both the sources were powered. Okay, so that is what superposition theorem conveys. Remember, we'll do this question also, but still right now I'm telling you, do not remove the dependent sources present in the network. Okay, so once we start doing numericals based on superposition theorem, we will see how to why I wrote. You'll understand why I wrote this. Okay. Now, in a concept, because we have covered what are linear networks, I'll just for the next part I'm telling you what is a homogeneity principle. Okay, because we know what are linear networks. What are linear networks? Anything which is resistive, probably inductive, capacitive, even sometimes transformers or other linearly controlled devices. Other linearly controlled devices. What would be linearly controlled devices? Again, a diode is not a linearly controlled device. Why? The characteristic is, the VI characteristic is what? Non-linear. But for our sake, what do we take? We take the linear part of our response, right? Right? So all such networks which are made of R, L, C and other linearly controlled sources, those would be what? Those would be linear. But all linear networks will definitely follow the principle of homogeneity. Now let me explain what is homogeneity. See, in this, for now do not see this part, okay? Just look in this part. Okay, I have a 12 volt source. If I have a 12 volt source and this is the circuit given to you, what will be the current flowing in this branch? Tell me, can you calculate the effective resistance in this network? What would that be? 6 is parallel to 6. So that makes it 3 ohms. What would be the resistance equivalent here? 3 ohms. Now this 3 ohm and this 3 ohm would be in series. So the effective resistance, in case you can calculate, would be 6 ohms. So the current in the from the battery would be 2 amperes, and because these two are what? These two are equal. These two are equal resistances. The current would divide in equal magnitude, right? The objective of telling you all this is, I want you to understand in case I multiply this excitation by some constant value, say k, and in our case k is equals to 3. So what do we observe? We observe that each response is also keeping the rest of the network unchanged. The network is not changed. What we are doing is we are changing the excitation by a constant value. We are multiplying the excitation by a constant value k. In that case, the response in each branch would be multiplied by the same factor. That is what is homogeneity principle. The objective of teaching you all this is all linear networks exhibit homogeneity. Okay? All linear networks exhibit homogeneity. Right? So, moving on. What I'm trying to say is, in case the excitation is multiplied by 3, if you calculate, now in our case, please calculate it for yourself. I'm not going to tell you each and everything, but it's and also it's very easy. That means you actually don't need my help in this. Okay, and in case you have any doubt, please, put up a question to me on WhatsApp personally. You have my numbers on the Sarthak WhatsApp group. But for uh, for for uh, for this time, like, understand how the excitation, if multiplied by 3, would also result in the change in response by the same factor 3. Or in general, if the excitation is multiplied by k, the response would also be multiplied by k. Okay, so all linear networks exhibit homogeneity, and so I've explained you this. Okay, moving on. Today let's take just an example on how to find current. Okay, I haven't given you the current. Let me write it down here. Tell me, one thing you need to be aware that every resistance is 1 ohm. Now, tell me step number 1 of a superposition principle. The first thing is we need to ensure if the network given to you is what? Is linear or not? Is it linear? Because it is purely resisted network, it is linear in nature, right? So yes, superposition would apply here. There is no doubt about it. The second thing that we say is we reduce each we reduce each independent source to 0 one at a time. Okay, right? So in our case, for starting, I'm reducing 1 ampere source to 0. That would be our case 1, right? Now, can I say our network reduces to? Look closely and tell me if I'm correct me if I'm wrong. Okay. And we have a branch which is connecting like this, right? Right? Tell me, there is a resistance between, let me name, for now our convenience I'm naming them, naming them. Tell me, there is a resistance between point A and C. There is a resistance between point A and C. Yes, there is. Can I, for the sake of our simplicity, insert a resistance like this? It makes absolutely no difference. It makes absolutely no difference. But, now you can, more clearly observe that the network is what? The network is a balanced bridge, right? The network is a balanced bridge because each resistance is given to be what? 1 ohm. So there will be no current flowing in this branch. So can I say the resultant would become what? There is a 1 volt battery here. So this makes 1 and 1 2, 1 and 1 2, and this is a parallel combination which makes R equivalent to be what? Again, just wait a minute. Just wait a minute. We don't even need to go till there. Did are you people convinced? Are you people convinced that it is a balanced bridge, right? And the current I1 here, the current I here was what? It was in the current in the branch A and C, right? This one in the 1 ohm resistor connected between A and C. But we know it is a balanced bridge. Can I safely say our current for the case 1, current for case 1 is equal to what? 0 amperes. Is it safe to say that? Right? Can I say that? Now, coming back to our case 2. This time I'll be reducing 1 volt to 0. And tell me how to reduce a one voltage source to 0. Did I tell you? How to reduce a voltage source to 0. Source, okay? This is 1 ampere, this is 1 volt. Please don't confuse it with the Roman number 4. It is 1 volt. Okay? How do you reduce that? We reduce it by a short circuit. So I'm drawing it for you. Tell me if I'm correct me if you find me wrong. Now you understand why I took a lecture on series and parallel before this? Because sometimes we do understand, we do know how to solve questions and how to approach questions, but it is always good to go through our basics, right? Right. Now see, this is your 1 volt, every resistance is 1 ohm. Okay, this is your 1 ampere and every resistance is what? And the current asked to you is here in this branch. Now I'm just naming the nodes. This time please don't confuse these ABCDs with this previous one ABCDs. Okay, if I write this to be point B, if this is point B, this is connected through a short circuit. So can I say this is also at the same potential B? Right? Let me call this one as point C. Right? Right? Is it clear as of now? And there is a between point A and C I have to find the current. See, if this is 1, this is 1. Between A and B there is a resistor. Between A and B there is a resistor. What have we learned from the concept of parallel? There should be same starting point and the same ending point. So is it safe to say these two are in parallel? Similarly, same starting point, same B starting point, C starting ending point, B starting point, C. So these two are also in what? Are in parallel, right? I'm redrawing this for you. Look closely. I hope this is not, this understanding is not a problem. And if it is, please post it on, live chat. Only then I will understand. See, if you guys don't interact, I will not understand at what level I have to teach you, okay? So please stay interactive in the lecture. This is 1 ohm. This is 1 ohm. This is the current I which was asked, right? I've reduced these two to half, these two to half, and still this one stands, this one is 1 ohm, right? Now 1 ampere current flows here, it will divide in this direction and in this direction. What have we learned about current division principle? Tell me. What do we know about current division principle? Current divides in the ratio opposite to the resistances. So in this branch the resistance is 1 by 2. In this branch the resistance is 3 by 2. I have to calculate the current in this branch, the 3 by 2 branch. So I will write 1 by 2 upon 1 by 2 plus 3 by 2, right, times 1 ampere, right? So can I say it is 1 by 2 divided by 2 times 1 again is equals to 1 by 4 ampere. This is case 2. And what did I say? Again the direction is same, okay? And what did I say? In superposition theorem we need to understand that it is the algebraic sum. What was the current in the first case? So in first case it was 0 amperes and in the second case it was 0.25 amperes. So our resultant current, actual current which would have been flowing if both the sources were running simultaneously would have been 0.25 amperes. Simple answer. Any problem as of now? Any problem as of now? Does this make sense? See, I don't see a lot of people joining today. Tomorrow, if a lot of tomorrow, I suppose I'll just take numericals on based on superposition. Because in case you start even missing these lectures, then what's the point covering such lectures? Okay, right? So tomorrow let's take a lecture on again. I'll schedule a lecture on simply just strictly based on numericals on superposition. Let me check with the rest of the faculty if tomorrow is a holiday or not, and I'll post it on the group. Okay. See you tomorrow.